So first question is about third unit, how the map reduce driver code. So we know there is four parts is there, no? Driver code, map function, reduce function, and we have another one, recorder and partitioner. We have various types are there. Have you remember the unit or not? I don't know. So there is a driver code, mapper code, and a reducer code, then partitioner, and we have combiner. So these are the parts we have to remember in a map reduce program. So regarding that we have to write write about the driver code in a Hadoop map reduce. Then describe about the old and new. So API you can divide and we can write, or we can describe individually separate what is the old and new API. So I give along with the program also. So what is the difference between old and new APIs? How the code will be changed? So how the configuration settings were there? So that I will explain. Then another one is about the right comparable interface. What is the right comparable interface? And another one is about primitives, Java primitives, wrapper classes, how what is the serialization and deserialization based upon that we have, right? Then explain about the implementation of raw comparator. And so we generally in Java we have Java comparator code, but we are going to be go with the raw comparator in order to optimize the solution easily. For that only we are going to be use the raw comparator. So these are two questions. Then another one is about write big nodes on distribution nodes running in pig script. So how to run a pig script. So then another one is about illustrate about Apache type. So just simply we have to write architecture diagram, and we have nearly working with the 10 is there, no? 10 steps. So we have to write the 10 steps. So if you have any doubt, you can ask me to Google Classroom or in WhatsApp. I will respond based upon your query. Okay. So that was your assignment too. And now we will discuss about today's topic, that is Unit 6. How about this Apache Hive? We already discussed all those things, but we need to discuss based upon the syllabus and based upon the queries what they ask in the examinations. By that we need to learn. For that only I prepared this PPT especially. So if you remember that, I will send you both PPTs, no problem. So after the class, I will send the all the PPTs to you through Google Classroom. You can find it and you can write the assignment. It will be helpful. So this is a thing which is the unit 6, applying structure to Hadoop data with Hive, saying hi hello to Hive, and seeing how the Hive put together and getting started with Apache Hive, examining the Hive clients and working with the Hive data types, what are the data types are there, then creating and manipulating the database and tables. So we already know that this is a platform where we are going to be develop the queries based upon the data set. So if you remember that the 10 steps of Hive working flow, if you remember these things. So where we have a meta store is there, through where from there we have a meta store data. So we are getting and we are searching that queries based upon the metastore related data only. So that's why only two times. Once first time we are going to be checking the query with the metadata, and the seventh step 7.1 is there a substep. There we are going to be checking with whether the metadata is accessing or not. So that is whether the physical data is available. That data in the data node. So we know the name node is a data node, what is the name node and data node, and what is job tracker and task tracker. These are the functionality. Again, we are going to be performing map reduce operation. We are going to be performing this. Okay, seeing how Hive data manipulation language works and querying and analyzing the data. So simple first one is about how saying hello to Hive. So Hive provides with a bridge to the RDBMS world and provides an SQL direct known as Hive Query Language. That is HQL we made on a top, or we can have Hive QL, which can be used to perform SQL like tasks. So that is SQL simply meaning. So we are going to be giving a query that is a general SQL, what is the data manipulation, the DML, DCL statements. No? So how we are going to be operate the tables. So there we are going to be operate the tables with the minimum numbers only. Here we are going to be operate these tables. A huge number of data is going to be flow at the such that the data is going to be stored in the warehouse. So generally we are going to be store the data in warehouse. The data storing itself, we are going to be keep it simply you can just throwing all the books at your home, or else we are keeping, okay, send one books, this one, send two books. We are keeping separately. All the books are going to be separate. Same like before going to be store the data in their data warehouse, we are going to be make some structure to the data, and we are keeping the data in a structure oriented data warehouse. So that is it. Hive is also made possible the concept known as enterprise data warehouse. So this is an enterprise data. We simply know about how up to now data warehouse. Then what is enterprise oriented means? So enterprise oriented means the data is structured data is available over there in enterprise data warehouse. So whenever the client is asking queries based upon the data warehouse, they are going to be fetch the data and sending to the user. So enterprise means generally how it is used in a specific organization, how they are going to use these data. So then enterprise data warehouse, EDW, and augmentation. A leading use case for Apache Hadoop, where the data warehouse are not, sorry, where the data warehouse are set up as a RDBMS built specially for the data analysis and reporting. So we know what is the reporting and we know what is analysis. Analysis means we are going to see the result on this top of the interface. So that we are going to be analysis the data. So reporting means we can generate thing and we can download and we can view the data for later. Reporting means that. So after particular query is given, what is the data is come? The data we are going to be storing maybe Excel file or maybe PDF file. We are going to be store the result in a particular query. So what is the result? Everything is going to be respond based upon the queries. So that we are going to be storing. That is known as a reporting. So Hive is closely associated with RDBMS or EWD, sorry, EDW technology is extract, transform, and load the technology. So that is ETL, extracting, transform, and load technologies we are going to use. Then, for example, a company or an organization might extract or understand the text data from the internet form or transforming the data into a structured format that both values and useful. Then it is load the structured data into its EW. So that is the enterprise data warehouse. So I already told you we have data is available. The data we are going to be keep storing. The storing itself we are going to be arranging. That is we have given some structure to store the data. So that is means we have some columns we are going to be send the data and keeping in the data warehouse. Okay, so there is a structured format, data in the structured format. Okay, so such that it is very less time to take the clients to engage with the data is very easy. So that is the meaning of this one. So Hive simply it is like a query language that is a HQL we can call, and it is a usage possible to make the concept of enterprise data warehouse purpose we are going to use. It is closely related with RDBMS and DWD technology, that is a table and column technology. So what is the main purpose is here to extract, transform, load the load technology we are going to use. So what is the data? So that data we are going to be extract. Then we are going to be transfer the data, and later on we are going to be load on what interface. So then it is creating the data in a structured format and keeping the data in warehouses, EW. So Apache Hive gives a powerful analytic tool all within the framework of HQ. So Apache gives a powerful analytic tool how to analysis data analytics. It is a simple meaning of saying hello to Hive. Okay. Then seeing how the Hive is put together. In Hive is put together. So the architecture of Hive we are going to be see here. So what is this? I think previous diagram and this diagram. Previous diagram is a total this parts we have explained. Even that parts, what is the internal behavior? So how these clients and Hive process and the distributed storage and processing framework. These are the side you can see this here. Administration. Consider. So administration and server coordination, client application and Hive and processing framework resource management and distributed storage. So this is a Hive architecture in details. So in the previous class we discussed about only we have a user interface, then in between we have map reduce or and we have something, then it is going to be total going to be stand upon HDFS return. So same HDFS is available here. In above phases, we have some in detailed explanation on this architecture. So here we have the administration server coordination, Hive web interface we have, then SCL CLI. What is the CLI? Command line interface. Hive's command line interface and HTTP. So Hive user interface. So what is this command line interface means? Where we are going to be execute the commands. So one statements we are going to be execute. So that I will show you here. Even we saw it. So how to Hive is going to be start. So something we previously we installed Java and Hadoop we install later. Once we are going to be verify it, how we are going to be verify Hive and greater than symbol is going to be started ready to execute the command. No? So there we are going to be run each and every command one by line by line. So if you are giving command, then particular output, giving command and particular output. So that you can simply say that interface, compiler and interpreter, no? Interpreter, line by line input where we have and line by line compilation and what is the output for line by line distribution. So that is a command line interface. So there we have a client applications that is a Query SQL and Microsoft SQL we can use, and Hive thread clients and Hive JDBC drivers and Hive ODBC drivers. All those things are there in the client applications. Then total things we are going to be keep on this Hive thread server, then Hive drivers, metadata, and Apache DB. So this is where we are going to be stored the data. So that is it. So these are the client operations. Simply we can say that we are going to be given a query to that. Then query is going to be executed on the metadata and the database. Then it is going to be submitted to the map reduce or N or 1 and 2. So we have a specific meaning for this map reduce version 1 and version 2 and ARM and test. So these total we are going to be have standing platform for all those things where the HDFS gives the information. So the distributed framework is going to be performed on the queries language. So these queries are going to be executed and to store the data in a structured format in RDBMS table. Okay. So meaning that above figure we can see that at the bottom we have a Hive site. Hive sits on the top of the Hadoop distributed file. So we know that the total diagram is sit on this Hadoop. So this is the Hadoop, and the total diagram is sit on this. So that's why we can simply say that sitting means we can simply say that platform. So the HDFS gives a platform for all other these sub projects. We know that these Hive and Big and all those things are the sub projects of the Hadoop system. So where we can stand on. So that is it. So above figure you can see that at the bottom of Hive sits on the top of the Hadoop distributed HDFS and MapReduce system. So in case MapReduce, in figure 1, both Hadoop 1 and Hadoop 2 components are, that is the MapReduce 1 and MapReduce 2 components are there. Okay. So with Hadoop 1, Hive queries are converted to MapReduce code and executed using the MapReduce V1, that is a MapReduce MRV1 version 1 infrastructure like job tracker and task tracker. With Hadoop 2 and N has decoupled resource management and scheduling from the MapReduce framework. So these are the two different, that is version 1 and version 2 is there. How we are going to use one. So Hive queries are converted into MapReduce code and executed by using version 1. Version 1 infrastructure like job tracker and task tracker. So this is the one. And with Hadoop 2, ERN has a decoupled resource management and scheduling from the MapReduce framework. Okay, so this one. Hive queries can still be converted to MapReduce code and executed. Now with MapReduce version 2 and ERN infrastructure, Hive queries can still be converted. So again, it is converted. So before it is going to be run the queries, how we are going to be clean the Hive queries. Hive queries can still be converted to MapReduce code and executed. So now with version 2, the ERN infrastructure will be used. So there is a both are combinedly we are going to be use some infrastructure. There are new framework under this development is called Apache Test. So with this design to improve the Hive performance, both batch style queries and support smaller interactive is also known as queries. That is a real-time queries also we can solve the problem. Why means again here we don't have any still constant database we are not going to be maintaining. So the database is going to be daily, is day-to-day updated database will be. So sometimes it may some real-time queries also is to solve. So such type of real-time queries also is going to be solved easily on this platform. So there is a new framework under development is called Apache Test, which is designed to improve Hive performance for batch style queries and support the smaller interactive. Is also known as a real-time queries. So this is a important. So HDFS provides the storage and the MapReduce provides the parallel processing capability for high-level functions with the Hadoop ecosystem. HDFS provides the storage and the MapReduce provides the parallel processing capability for higher level functions with this Hadoop ecosystem. So one for storage, another for processing. How we are going to be do the ecosystem, all those things. So moving with the diagram, we can find the Hive drivers which compiles and optimize and execute the Hive query language. So we know that the Hive is similar like SQL queries. So if it is like this, so we know the process how the interface is sending the query to the compiler, then compiler sending the queries to the next anyone. So compiler where to send these queries? Compiler where to send the queries? So interface sending to the driver sending to query to the compiler. Then later, anyone? Just now also I told you earlier. So before checking the query, so what maybe for example if we are saying select star from table reason. So we need to check with the table is available in the data store or not. That is the meta store is containing that particular data table is there or not. We need to confirm it before proceeding. Okay, before proceeding, we need to confirm. So that's such that only what is going to be happen. The interface is going to be connect with the drivers. The driver is connecting with the compiler. The compiler is connecting with the meta store. Through that meta store, for example, if simply I said that there is a table name. For example, if it is not a table name, for example, we mentioned something column names in that. So have you remember that, for example, how many kilometers flight in one simple query is there in the quick script we learn. Same like that we can view any query there. We have number of columns are there. So here we need to check with whether the columns are available in that particular data set is there or not. That is going to be checked before processing the query itself. So that is a high level, higher usage of higher privilege we are providing the query before going to be executed. Okay. So now meta storage is there. The query is going to be checked with the meta store. So is the particular column names are available in the particular meta. Then ready to proceed. Then it is back to the compiler. Okay, compiler check properly. It is done. Then it is sent to the drivers. Now the drivers to it is sent to the execution part. Then execution part to map reduce part. So once the query is submitted to map reduce operation, now it is to find the where the physical data available. So that is a 7.1 step, if you remember. So that is physical data is going to be get it from the meta store and it is storing into the data node. Once the data is transferred into the data node is contains the original physical data, particular data. Then it is going to be produced and it is going to be submitted to the that a particular task tracker and job tracker in order to complete the map reduce operation. So where we can perform on this. So the Hive drivers may choose the execute the Hive QL statements and commands locally or spam a map reduce job depending on the task at hand. By default, Hive includes the Apache DB RDBM is configured with meta store, which is called as embedded mode. So we already know that so there is a three different ways of running Hadoop. Have you remember? The Hadoop we are going to be running three different modes: the local mode and pseudo mode and fully embedded mode. Have you remember or not? So for that one I shown last class. So how it will be in the second unit we discuss it. Working with HDFS data, working with Google file system. Then we have building the parts of Hadoop. Then later we have three ways of running Hadoop system: local mode and the pseudo mode and uh, fully embedded mode. So there is we are going to be select anyone. So the default configurations. So the new Apache all those things it is a configuration you can do it user level itself. If it is not do, then it is automatically take it as a default mode as embedded. So Hive includes Apache nearby RDBMS configured with the metastore in what is called as a embedded mode. So embedded mode means that Hive drivers the metastore and Apache nearby all nearby are all running in one Java virtual machine JV. So that is Java virtual machine. All those things are running. This configuration fine for learning purpose, but embedded mode can support only a single Hive sessions. Normally it is not used for multi-user production environment. So simply we can learning purpose. For example, if I want to explain how the data is processed. For example, one client is going to be giving a interaction with some product based upon the data. So for that one particular mode for learning purpose or explaining purpose, we can go with this embedded mode, but it is not going with supported for multi-user production. So for that, we have to go with single different mode of multi-mode production environment we have used. So for simply embedded mode, it is not possible to interact with the multi-user. So for single purpose only we can use it. So the simple meaning is it is a single purpose means it contains a local system. The data local system data only it is going to be take it and it is going to be processed. So it is not going to be fully embedded. So it is a embedded simply embedded with the local system. And the two other existing modes are local mode and remote mode. I already told you. No? So local mode, remote mode, and embedded mode. So the two other modes are exist local mode and remote mode, which can be better support the multiple Hive sessions in a production environment. So the local mode or other pseudo mode we can use for production environments easily. So also you can configure any RDBMS that complies with Java database connectivity, that is a JDBC and application programming interface suite. So the API. So that's simply meaning a JDBC APIs we are going to be configured. So how to store the data in the RDBMS tables. So the key to application supports the Hive threads server, which enables a rich set of clients to access the Hive subsystems. So we can access the subsystems. So we have Hive thread server is there. So to access the subsystem of particular part, particular queries, we can sub queries we can run it and we can approach with simple applications which we are running on the Hadoop system. So that is it is all we already know that these Hive and Pig are the subsystems of these HDFS, so that we will be very useful. The main point is that any JDBC compliant application can access Hive via the bounded JDBC drivers. So bounded JDBC bundled. So that is a combining. So Hive via with the JDBC drivers. So if I will show you the diagram, remember. So there is a Hive thread. See this, the client applications we are discussing. So Hive thread server. So these Hive thread server, JDBC driver, and ODBC driver. These all are the client applications which stand on the Hive server thread server. So there the server is going to be Hive server is going to be showing on the applications which are so the same statements applies to the client compliance with the open database connectivity, that is the ODBC. For example, Unix ODBC is the SQL utilities, SQL, ISQL utilities, which are typically bundled with Linux and enable access to the Hive from remote Linux clients. So the statements apply to the clients compliance with open database connectivity. For example, the Unix, ODBC, and ISQL utilities, which are typically bundled with Linux. Okay, so how we are going to be bundled with it? So we already have these JDBs and ODBC servers in client applications. These applications are, we have a platform for that is a Hive thread server where it is going to be provide the application. So enable to access the remote clients. So additionally, if you use Microsoft Excel, so these are the client applications we have. So additionally, we can use a Microsoft application. If you need, if you will be pleased to know that you can access the Hive after you install Microsoft ODBC drivers on your client system. So once it is installed in your system, then it is automatically enabled these Microsoft Excel. So where we can access the previous Pig we have CSV files, how we are going to be access. No? Same here, the files we are going to be access Microsoft Excel files that we are going to be keeping in the meta store. If we want to connect this Microsoft Excel, definitely we need to connect with Microsoft ODBC drivers client system on your client system. So the client system must contains this Microsoft ODBC connectivity should definitely. So finally, if you need to access a Hive from programming language other than Java, so other than Java means it may be a PHP, Python, or any example. The Microsoft depth is the answer. So why we are using this Microsoft Thread server means. So if we are not only prefer for Java, we can use other languages, maybe a Python or PHP, any other language we are using to communicate. Then definitely this answer for these all questions. So Apache Thread client connects the Hive via the Hive thread server just as a JDBs and ODBC clients do. So how it is going to be perform the connectivity and the same the servers how we are going to be done. Once it is connectivity be done, the client is easy to access the connectivity of this. Then it is easily approach the metadata to access this. So Hive includes the command line interface that is I already told that is the top of the our architecture is there. Hive user interface, then we have Hive CLI command line interface, where we can use a Linux terminal window. So that is terminal window. We know simple one window we are going to be open to perform the programming on Linux operating system terminal. No? So that is a Linux terminal window to issue the queries and administrative commands directly on the Hive drivers. So administrative commands directly on the Hive drivers. So Hive includes a command line interface. So command line interface means one after one. So even I have a simple how we can perform one by one line. So that I will show you. So simple it is going to be start with the Hive greater than symbol. Then where we have to run 111 command and we can get a easy interface. So simply how we can remember SQL it is open. SQL it is going to be start greater than symbol. Then we are going to be run type something command, for example select start from table name. So simply we shows what are the tables contain rows and columns it is totally printed. So if a graphical approach is a more use your speed, there is also a handy web interface so that you can access your Hive managed tables and data via your favorite browser. So you can access these data on the browser itself. So the graphical approach, how we are going to be see this statistics, how we are going to be see the statistics. On your own speed, we can see these all those data on the web interface itself. It's also handled by the web interface so that we can access your Hive managed tables and data via your favorite browser. So I will show you how the browser will be there, how it will be. See the some other slide I have. So getting started with the Hive, Apache Hive. So we are running Hive is in a standalone mode rather than the real life Apache Hadoop cluster. So configure the system to use local storage rather than the HDFS. Simply set the, so this is the parameter we are going to be passed to set a local or real time how we are running. So hive.metastore.warehouse.dir. So this is the parameter we are going to be passed for a local storage rather than the HDFS storage. So we already know that there is a various ways of how to run the Apache Hive. So that is group mode or single mode, or local mode or distributed Hadoop mode also. So when we start a Hive clients, so there is a dollar Hive underscore home environment variables to tell the clients that it should be look onto the your configuration. So that is, so we have various XML files are there now. So there is a core site.xml, that is earn site XML, earn.xml. We have a lot of XML files are there. We are going to be configured. So this Hive site.xml on the configuration directory we are going to be used. So here we are simply saying that how we are going to do the configuration. So the detailed configuration information I explained in the last PPT. So how to install Java and how to install the Hadoop system. Hadoop itself we are going to be selected for pseudocode mode, how we are going to be installed. Once we in the pseudocode mode, Hive is installed. Again, we are going to be configure via with various XML files, .xml files we have. So all those things are we done and we proceed. So that is the configuration directory. If you already have a Hadoop clustered configuration running, if you need to set the hive.metastore.warehouse.dir configuration variables to HDFS directory, where we intended to store your Hive warehouse. So set the map.job.tracker configuration variable to point out your Hadoop job tracker and set up the distributed metastore. So we need to perform our, so we know the job tracker is going to be perform the task, and job tracker is going to be job tracker and task tracker is two types. That is a job tracker is going to be see about how the distribution is going to be performed, and one how we are going to be sending the data and how we are going to be processing. So these HDFS directories where we can intended to store your Hive warehouse to set the map job and tracker configuration variables to point out your Hadoop job. So how these job tracker and task tracker functions are going to be executed. So examining the Hive clients, how we are going to be examining the clients. So here the three modes of clients are there. So in the clients simply we can how we are going to be run this. So how we are going to be run this. So whether we are going to be run on command line interface or web interface, or we can use some SQL that is a SQL clients using JDBC drivers through the driver codes we are going to be running. So one we have how we are going to be. So second and third is about we are going to be run on the browser. The servers we are going to be run on the browser, and HCL means we can use directly. The simple meaning is, for example, so your database is there. For example, how your database is going to be connected to your web page. Okay, how we need to connect the database to your web page. How we are going to be connected with this. So if you want to connect, what is going to be happen? So that simply queries we are going to be used on the text box on the top of your interface. There we are going to be select and we are going to be operate. So there we can use all those things and we can perform. So for example, if anything a problem with the database table, it is not showing on this, what we are going to do? Simply we can open your database and we can check with the queries. Okay, if this query is given, the particular output is going to be given or not. So how it is going to be performed and how it is going to be operated, all those things is a basic level. So simply last class we discussed about pig script. So one for testing purpose, another for group running purpose we saw. So in order to test one command, same here also. So if the database is there, how we are going to be see the data in the command line. For example, simple one query you are giving. Based upon that query, it is going to be organized and showing on the table or not. That is going to be simple. The terminal itself. The first one is going to be performing the terminal itself. And the second and third one is about how we are going to be shown on the browser. How we are going to be shown on the browser. So once it is running as a queries, we are going to be used. So based upon the queries, how the data is going to be shown on the server page. That is the server page means simply we can see on the browser page how we can. So even I have some sample browsers how the data is showing on the browsers. That also I have. So the first one is about Hive CLI. So that is a command line interface. How we are going to be use the command line. So see here. So we have a Linux terminal we have. So there it is going to be start with the Hive and greater than symbol. Now it is the terminal is ready with running with this Hive SQL queries. That is simply we can call HQL queries. HQL means Hive query language. No? So that is the Hive query language is ready to run. So the client is going to be run here. Then it is going to be transferred to Hive CLI command line compiler is there again. So then it is going to be transferred to the driver to metastore. It is going to be checked. So when it is going to be have then Apache there by DB, then it is going to be shown the data on the interface. The figure shows the components that are required to when running the CLI and on the Hadoop cluster. How we are going to be run on this Hadoop cluster. So one command how we are going to be run on this that we are going to see. Okay. So the example in this particular part. So we run Hive in the local mode, which uses local storage rather than the HDFS. So that's only. So in this Hive HCL, that is a CLI command line interface, we are not going to be gone through the Hadoop system. We are going to be simply to have two parts. We are going to be simply run it, and it is searching for the metadata, and it is showing the result. So we are not going to be talk about how we are going to be submit the data to the Hadoop system. We are not going to be simply here. We are going to be seeing one command whether it is executing or simply we can call again the manner of pig we can call it is a testing purpose also we can use. So Hive commands to specify this CLI we want to run the following instructions showing Hive statements like this. See that? So we have this Hive statement. For example, first one is Hive home bin Hive minus minus server client. If you view, then start with the HCL that command prompt it will show. That is simply in the terminal it is ready with the environment. Now see this Hive greater than symbol is there. Now I am going to be set the environment. So these are the things we discussed. How we are going to be set the environment variable, how to set the path, all those things. No? Same here also. So see here. So then we are going to be set for the CLI to print the current database. To know how to the namespace, we are going to be use these commands set the path. Then Hive default create the database table. So the database table is so create database. So the table which we are using here is our first database. So this is the table name we are going to use. So see that the description Hive QL tell the system to create the database because our first database. So it is going to be given as a name as that. Then Hive default is used our first database. Whenever you can, so we are creating a database here. Then we are ready to use our first database. Once it is ready to give, then what is going to be happen to this? So it is going to be up to this is the default one. Once it is uses, so our first database that the table name is going to be sent to the Hive. So if you remember that previously starting with the lab will be there, lab at the Red Hat server will be there. Once you are going to be log in with your username, it is going to be sent inside IT maybe 24 or 35, IT at the rate of 24, 35 at the local server or local host will be define the name. No? Same here it will show. So create a table, our underscore first table. So see that first name is a string and last name is string and employee ID is integers. So how we are going to do? So if you remember the SQL queries, how we are going to use the columns and how we are going to be mention the data, what type of data we have to store in that particular columns, so that it will use here. So we can create our first table and use the name as a our first table name. So this one is creating a directory database we are going to be create. In that database we are going to be creating table. So see that this is our first database we are going to create. So here in that database we are creating table. So if the table is contains the three columns, the first column is about string, that is a name, first name, second name and employee. So what type of data? So that is the first name is about string and last name is about string and employee ID is about integer. So that information also we are going to do. So once we can view, so it is actually justified. That's why it went to there. I will adjust the concealer. So this is not. So this is the simple. So in a second, I will show you again. See that? So dollar with ls if we view list. So home BIDA, so that is a by admin Hive warehouse and first database is contained .db, which already created .db database table. In that database table we have our first table. So that table is done. So like that we are going to be execute Hive commands with line by line how we are going to be executed. So see that? So simple how the SQL queries we are going to use. In a similar manner we are going to use here also. Same. Okay. So create database or first database, then Hive default. So whenever we can use this database, that database name is sent to inside this one. So once it is sent inside, then we create a table, our first table we are going to. So then we are going to be send all those things inside. Then we are going to be listed what the tables are contained. So we created one database table. In that database table, database we created, in that database we have one table. So that is the table. So Hive warehouse is directly and stores the our first table on the disk. So by that way we are going to be create and execute the database tables. So that is about simple. The first part of client part. This one is about Hive HCL. So that is CLI, command line interfaces. How we are going to do that. So still anyone having doubt, you can ask me. So today we saw about what is the use of Hive, then why we are preferring Hive, and how to organize the data on the this. Then we saw the overall architecture and what are the various parts in that architecture we saw about, and various clients how we are going to be run on this. Three ways are there. One is about HC, that is HCLI, so command line interface. Remaining two are the browser related things. So how we are going to be doing all those things. So anyone having doubt, you can ask me. We will discuss 2 more minutes on that. We will see the second and third part tomorrow. Tomorrow third hour is there. We will go to the third hour. So tell me anyone having doubt, you can tell me.